Okay, so there's a couple of things that we need to consider. Now we have had a matrix, and if I just comment all of this out, I'm going to go back to my original matrix, and in this moment start taking this away. So if we execute this command here with clear command window, we should be able to have our matrix as defined previously, and we can use it as a network matrix. How does such a matrix come to represent a network? The way MATLAB incorporates this information is to go for a row and look whenever there's an element that is non-zero, for example a 1, and then check which column that is and connect the row to that column with an arrow. So it interprets the rows and the columns as nodes of the matrix and the information in the off-diagonal elements as instruction to put an arrow between the corresponding nodes. So the thing that we need here is basically two things. We need to know how many nodes does the matrix have and how many connections are there, how many edges are there. So let's first take a look how many nodes do we have. It's very easy because Rob showed you already. It's use the size command. The size of my matrix, but if we take either the rows or the number, will show you the number of nodes. So if you execute this command, you can see on the control panel the answer is 5, means my matrix has 5 nodes when it is interpreted as a network. Second thing that we need is we want to find, maybe clear our window, we want to find the edges. How many edges are there? And one way to do it is to use the find function, and find can be used such that we say wherever my matrix is equal to 1, call this my assign this to the edges. So what will this do? Find will take a look at this whole matrix. We'll try to find out whether there's a 0 and a 1, and whenever it finds a 1, it will give you the corresponding index where that 1 stands. So if we execute it as it is, what we see, we'll find a number of indices. How can we interpret these indices? Because they are only one number. So we need to understand how is that one number obtained. It actually, if I display my matrix, which is here, then it takes the first column and counts from top to bottom. So the 0 in the upper left corner is element number 1. The 1 below it is element number 2, element number 3, element number 4 is a 0, so it's not detected, and the 5th element is detected, so that's why we have a number 5 under the edges, and so on. It will then continue with element 6, and so on until it reaches 25, which is not an edge, so there will be no display. The last that it finds is element number 24, and you can see it's highlighted here as element 24. So, but that only shows us the position of the edges, not how many edges there are. But we know, of course, the ways to get the number of elements. If edges is an array, as we have seen, it's a vector with a set of numbers in it, then we can just say, as we did before, the length of edges. And the length of edges, you can see on the left side in the command window, is 9. Meaning our matrix has 9 edges. So there's ways to check how many nodes there are and how many edges there are. And this is the information that we need, which will help us to go into Biograph.